The Arafura class offshore patrol vessel, or OPV, is the Royal Australian Navy's most modern class of minor vessel. Based on the PV-80 design developed by the German shipbuilder LRASM, which is currently operational with the Royal Brunei Navy as the Jerusalem class, HMAS Arafura is some 80 metres long, 13 metres wide, and displaces around 1,650 tonnes at typical load. The Arafura class has a top speed of 20 knots, a range of over 4,000 nautical miles, and can accommodate up to 60 personnel, although her typical crew is 40. The vessel contains a large helicopter-capable flight deck, and, although there are no permanent hangar facilities, refueling equipment can be installed. This flight deck can support the operation of medium-sized unmanned aerial vehicles, in addition to a number of 20-foot shipping containers. As envisaged, the Arafura class will have 4 primary roles: maritime border patrol, maritime constabulary, fisheries patrol, and humanitarian and disaster relief. Reflecting this intended mission set, the Arafura class are only armed with a 25mm Typhoon autocannon and a pair of 50 caliber heavy machine guns, at least in their initial incarnation. 3 deployable fastboats can be supported, with a pair of 8.5-metre RHIBs deployed by crane and provision for a 10-metre boat at the stern. Procured under Project C-1180 Phase 1, the 12-ship Arafura class OPV is designed to replace the much smaller Armidale and Cape-class patrol vessels. Currently under construction at Adelaide's Osborne shipyard, once the first 2 units are launched, the remainder will be assembled in the Henderson facility in Western Australia. The Arafura is a much more capable platform in comparison to the vessels it will replace. The Armidale class patrol boats, in comparison, displace just 300 tonnes. The larger size and greater displacement not only means the Arafura will be able to stay at sea for much longer periods, but also operate in much more dangerous sea states, something of substantial value to Australia considering the importance of its Southern Ocean possessions. The sheer size of Australia's exclusive economic zone, by area the 3rd largest in the world, makes endurance and range critical capabilities for any patrol vessel, and the improvement in these areas will enable the Arafura to achieve a significantly greater level of efficiency, allowing the fleet to be in more places more of the time. An important element of this increased endurance is the improved space and amenities for the crew, enabling longer deployments generally. The containerized aviation facilities are another substantial improvement. Unlike the Armidale, the Arafura has the ability to generate its own over-the-horizon ISR footprint through the use of medium-sized unmanned aerial vehicles, greatly increasing the area which a single vessel can effectively patrol. All told, the Arafura class is an excellent offshore patrol vessel, one which will excel in the primary roles for which it has been procured. Nonetheless, ever since the announcement of the OPV program in the 2009 Defence White Paper, questions have been raised as to the Arafura's potential capability in a high-end warfighting scenario. These calls have only become louder over the last few years, including analysis conducted by ASPI, in addition to numerous editorials in the Australian and Financial Review, openly questioning why the warfighting capability of the Arafura is being, at least seemingly, not only ignored by defence, but deliberately designed out of the platform. For example, the 40mm main gun has been deleted from the design, although this may be replaced by another system at a later date, and the helicopter refueling system, which was integral to the initial PV-80 and Jerusalem class vessels, has been removed. It seems as though there is a tendency within the ADF and Department of Defence to deliberately remove capabilities off a platform in order to avoid mission creep. In this case, currently the RAN does not intend to utilise helicopters with the OPV, so any ability to support them is removed, which in turn neuters any argument that the vessels may be useful in another role that envisages helicopter operations. A similar process can be seen in the development of the Canberra-class LHD and its ability to support fixed-wing aviation. If this is the case, then this is a deeply short-sighted manner in which to approach naval procurement. Mission creep is not inherently negative. In fact, through time and operation, new roles and uses for platforms can be developed, enhancing your aggregate capability. Indeed, it seems rather hubristic to assume that defence planners in 2022 have a perfect understanding of the situation the nation will face in 2032, and therefore are inherently wise to remove capabilities from platforms that could, in theory, allow them to perform other roles than originally intended. And, even if mission creep has historically been a problem, calcifying your platform's design by removing flexibility is not a wise way to negate it. It is these intended missions, and defence's focus upon them, that explain why the Arafura is so lightly armed. Unlike the minor vessels of most Asian navies, the Arafura is very unlikely to engage a hostile naval vessel of similar size. The Chinese Type 56 Jiangdao corvette, as an example, is practically the same size as Arafura. However, it deploys a 76mm main gun, 2 30mm autocannons, 4 YJ-83 anti-ship cruise missiles, an 8-cell HQ-10 point defense surface-to-air missile system, and 2 triple torpedo tubes. These weapons are supported by a number of sensor systems, including the Type 360 two-dimensional air search radar, Type 347D fire control radar, a bow sonar, and the Type 56A variable depth sonar. Considering the Jiangdao is actually a hair smaller than the Arafura, at least in terms of displacement, it is practically a frigate when one considers the number of weapons and sensor systems it deploys. This level of armament is similar in other regional navies. The Jerusalem class, upon which the Arafura is based, deploys a 57mm main gun and 4 Exocet canister-launched anti-ship missiles. The Vietnamese deploy 6 classes of missile-armed vessels that displace less than 2,000 tons. The primary reason why patrol vessels are so heavily armed in Southeast Asia is the sheer volume of disputed territory in the South China Sea. Almost every nation in that area of maritime geography has a claim to offshore reefs that are disputed by other regional powers, predominantly China. It is these small patrol vessels that effectively assert a nation's sovereignty over these areas of ocean. And with different regional powers all trying to do the same thing, the threat of conflict between these minor vessels is a very real one. Even when operating below the level of open conflict, it is important that a minor vessel not be completely outgunned by its adversaries in any standoff, as maintaining a credible ability to react with lethal force is a key component of maintaining deterrence. This is simply not the case for the Royal Australian Navy. Not only does Australia enjoy very friendly relations with all of its immediate neighbours, it has no disputed maritime borders. The chance of an Arafura class getting into a standoff with a hostile nation's minor patrol vessel is practically zero, and considering the primary tasks will be such things as intercepting vessels containing illegal migrants and fishing Australia's waters, the lack of armament certainly makes some sense. Nonetheless, although defence does not intend to use these vessels for anything other than EEZ and border protection, there remain other roles that the Arafura class could fulfil, which include high-intensity warfare. In fact, if embedded within a wider network and utilised within a specific concept of operations, the Arafura class could substantially contribute to a number of high-end warfighting scenarios. There are 2 major areas where the Arafura could, if armed and equipped correctly, significantly contribute to the ADF's high-end warfighting capability. The first is in a defensive naval campaign. For the first time since 1945, Australia now faces the prospect of great power naval battle in its immediate region. Of more concern is the fact that the alliance network in which Australia is embedded is now in an openly antagonistic relationship with an emergent great naval power, China. The rise of communist China, and especially the rapidly expanding People's Liberation Army Navy, poses the greatest strategic challenge the nation has faced since the existence of Imperial Japan. Much like World War II, in the event of general conflict in the Indo-Pacific, the primary threat Australia faces is the operation of hostile aircraft carrier forces to its north. Australia's geography alone poses a substantial strategic threat to China in any large-scale conflict. The ADF's northern basing infrastructure is well placed to stage US air power, allowing the Allies to potentially dominate vital areas of geography such as the Malacca Strait and South China Sea. Therefore, targeting the military facilities across Australia's north will certainly be a key objective for the Chinese in the event of any large-scale conflict. There are 3 realistic methods by which the PLA can effectively strike Australia's northern bases. The first is ballistic missiles. Australia's geography, however, provides a great deal of protection from this form of weapon. Although the PLA has a large conventional ballistic missile arsenal, the vast majority of these systems, such as the DF-21 and DF-16, are short to medium-range missiles. The only tactical ballistic missile that can engage some parts of Australia, essentially just the very north of the Northern Territory, is the Dongfeng 26, which has an operational range of 5,000 kilometers. Although the number of intermediate-range missiles is increasing, so is the sophistication and capability of US ballistic missile defense systems. The deployment of a THAAD battery to Northern Australia, as an example, would go quite a long way to mitigating the ballistic missile threat. Such a system could be air deployed to Australian bases within a matter of days. The second major threat to Australia's northern basing infrastructure is Chinese strategic air power. The PLAAF has a large number of H-6 strategic bombers, essentially a licensed copy of the 1950s era Tu-16 Badger. Although the original design is as old as the B-52, it has been kept relevant by improvements in avionics and standoff weapons, seen in the most modern variant, the H-6N. Equipped with the 1,500 km range CJ-10 missile, the Chinese equivalent of the Tomahawk, the H-6 does pose a threat to Northern Australia. The major problem facing the H-6 is how vulnerable it is to fighter defences. Even a single flight of F-35As, which could easily be forward deployed to stations well beyond the CJ-10's launch envelope, could pose a dire threat to an entire regiment of H-6s. Because of the F-35A's very low signature, in terms of both its radar cross-section and infrared emissions, any escorting fighters will struggle to prevent long-range interception. Newer missiles are increasing the H-6's capability, but this is being countered by the development of longer-range air-to-air weapons. Although the PLA's ballistic and long-range cruise missile capability is certainly some threat to Australia's northern bases, it pales in comparison to that posed by the PLAN's growing carrier capability. There is an old saying in warfare, proximity equals capability, and this is one of the greatest advantages aircraft carriers provide. In comparison to ballistic missiles, as an example, which can only be used once, an aircraft carrier can deliver a colossal amount of firepower over a sustained period. In terms of tons of high explosive delivered on target, there is really nothing that compares to these vessels, apart from a land airbase. This persistence is critical if you intend to overwhelm an enemy's ability to repair their infrastructure, allowing for multiple attack waves using large strike packages. An aircraft carrier task force stationed 300 nautical miles off the coast of Darwin could, over a week for example, subject RAAF Darwin and RAAF Tyndall to such a sustained level of bombardment that these key Australian bases could be crippled for months. Currently, the PLAN's carrier capability is embryonic. 2 units are operational, Shandong and Liaoning, which are both derivatives of the Soviet Kuznetsov class design. Although reasonably large vessels displacing some 55,000 tons and equipped with a reasonably large air group, their capability is somewhat limited. The Shandong, for example, can deploy an air group containing 2 squadrons of J-15s, essentially a reverse-engineered Su-33, about 32 in total. Both of these carriers use a stow bar arrangement, which entails the fighter using a ski jump in combination with an angled flight deck. This does reduce the total payload a J-15 can deploy with, although by using the long run-up these aircraft can take off with just over 6 tons, but this is dependent upon a strong headwind and limits the carrier's sortie generation rate. These 2 Kuznetsov-based vessels are being supplemented by a pair of supercarriers in the 100,000 ton range, the Type 3 and Type 4, the latter of which will be nuclear powered. These supercarriers will be generally comparable to the US Nimitz class. Unlike the stow-bar designs, these vessels will use an electromagnetic catapult, allowing for the deployment of fixed-wing airborne early warning and control and tanker aircraft. 2 of these platforms should be operational by the mid-2030s. Each one of these vessels will be able to deploy a comparable amount of firepower to the frontline fighter strength of the RAAF, with 4 squadrons of strike fighters, both the 4th generation J-15 and the 5th generation J-31. Unlike long-range bomber formations, strike packages generated from the Type 3 carrier will have integrated fighter escort, suppression of enemy air defense, and airborne early warning elements. Complete with its supporting battle group composed of Type 52D and C-class destroyers, and the Type 55 class cruiser, a Type 3 carrier strike group poses a colossal risk to Australia's northern basing infrastructure, the bedrock of the nation's defences. Additionally, the operation of Chinese amphibious forces in the Indonesian or Bismarck archipelagos, with the objective of establishing forward operating bases around Australia's periphery, poses an equally significant threat. Obviously, Australia is not alone, and a bilateral conflict just between the 2 nations is quite literally unthinkable. But the United States' carrier forces are dispersed around the globe. It may well take weeks for substantial Allied naval assets to arrive. In any case, during a general regional conflict with China, US assets will be badly needed all along the First Island chain, so Australia should not expect a disproportionate level of aid. In short, the ADF must prepare for a large-scale, high-intensity defensive naval campaign in its primary area of operations, conducted with only a minimum amount of Allied aid. But what can Australia do to parry such a threat, considering it has no carriers of its own to meet the Type 3 head-on? Well, one method which offers Australia a real chance of meeting this challenge is a concept of operations called anti-access area denial. Ironically enough pioneered by the PLA, at least in its modern incarnation, this concept relies upon the combination of long-range strike systems, such as anti-ship cruise missiles, and pervasive wide-area surveillance systems. The main idea is to have a very large sensor footprint that can rapidly detect, track, and classify ships over a massive area, potentially whole ocean basins. Then, saturate the enemy formations with long-range strike systems, which can be launched from a range that is well beyond the battle group's defences. This has been a core element in China's wider maritime strategy, and it allows you to rely on missiles, rather than ships, to successfully engage aircraft carrier strike groups and other powerful task forces. The ADF has invested heavily in anti-access area denial capabilities. The first link in this kill chain is JAWN. Over 40 years in the making, JAWN is the world's most advanced over-the-horizon radar network and provides the ADF with a massive sensor footprint. Its range is over 3,500 kilometers from the 3 transmission stations. By bouncing low-frequency radio waves off the ionosphere, JAWN provides both a wide-area surveillance and potentially target acquisition capability over a vast area of maritime geography. Nonetheless, JAWN still faces calibration and discrimination challenges, inherent problems with over-the-horizon systems. Because of the uncertain propagation paths through the atmosphere, it is often hard to know with certainty the exact area on the Earth's surface that the radar is observing. Another issue is phantom contacts. Because a single radar beam can take multiple paths to and from the target, a single contact can often present as a group of ships. Therefore, JAWN has to be supplemented with other surveillance systems. Powerful synergies exist between over-the-horizon radars and space-based surveillance systems. If an imaging satellite can take a picture of the target formation while it is being observed by the radar, this information can be used to calibrate the system, greatly increasing JAWN's accuracy. A satellite pass would also provide classification of the target, a key link in the kill chain. The Australian government does not publicly possess an imaging satellite capability. However, as has been indicated in several defence white papers, the Australian government does seem to have access to Allied imaging satellites, which is probably the American Keyhole constellation. Finally, the ADF has several long-range surveillance aircraft which can supplement a JAWN track, such as the MQ-4C Triton, high-altitude, long-endurance unmanned aerial vehicle, and the P-8 Poseidon. The MQ-4C is a game-changing capability for the ADF. A maritime development of the RQ-4 Global Hawk, the Triton can stay aloft for over 30 hours at an altitude of 50,000 feet. It has a total range of over 8,000 nautical miles. What makes the Triton so capable, over and above its endurance, are its sensors. Its primary ISR system is the AN-ZPY-3 multifunction active sensor. An AESA radar with a 360-degree field of view, the ZPY-3 can provide synthetic aperture radar images over a vast area, some 7 million square kilometers in a 24-hour period. The system is capable of taking synthetic radar images of vessels, classifying them in all weather conditions. The Triton is also equipped with the Raytheon MTS-B multispectral electro-optical infrared sensor, which is the same system used in the MQ-9 Reaper. The most critical capability the Triton provides in this hypothetical defensive naval battle is its electronic intelligence suite. Essentially the same system as utilised in the EP-3 electronic surveillance aircraft, the Triton's ESM systems can be used to passively detect, classify, and geolocate hostile electronic emissions, including radar signals. Because of how sensitive the Triton systems are, they can detect, classify, and triangulate the position of a hostile radar from a range that is far beyond its detection radius. This is, obviously, quite important when trying to engage a carrier battle group that can deploy dozens of fighters. In combination, JAWN, imaging satellites, and Triton will allow the ADF to locate, classify, and track hostile naval task forces, including carrier strike groups, at a range well in excess of 1,000 nautical miles from Australia's shores, including, potentially, the southern South China Sea. This information constitutes a firing solution on the formation. The next step in the A2AD kill chain is the use of long-range strike systems to engage the formation before it poses a serious threat to Australian infrastructure, of course accounting for long-range cruise missiles. In the ADF, the maritime strike weapon of choice is the imaginatively named Long-Range Anti-Ship Missile, or LRASM. The LRASM is one of the most lethal anti-shipping systems currently operational anywhere in the world. A development of the JASSM-ER, the weapon retains its stealthy body, power plant and warhead, simply adding a new seeker to allow for counter-maritime operations. Unlike the supersonic Russian and Chinese systems, which rely on speed to reduce the effectiveness of shipboard defences, the LRASM utilises stealth. Its low RCS airframe is combined with its passive sensors. The weapon emits very little electromagnetic radiation apart from its LPI data link. The LRASM uses a combination of passive electronic and imaging infrared sensors to find its target. Revolutionarily for an anti-ship weapon, the LRASM has advanced targeting software. Even if all communication has been lost, the missile can generate an electromagnetic picture of the battle space, plotting any hostile or friendly transmissions. The weapon is smart enough to then devise its own attack profile, determining the appropriate route to the formation and selecting high-value targets such as aircraft carriers. If numerous weapons are operating together, they form a network sharing targeting data. It then drops to wave-top level and relies on its imaging infrared seeker for terminal guidance. As the weapon emits nothing and has a low RCS airframe, it will be detected late, compressing the amount of time the ship's defences have to react. Because of the addition of the seeker, the LRASM has a slightly lower range than the JASSM-ER, probably around 400 nautical miles. Longer range variants are very likely to be developed. The LRASM contains the original 1,000-pound broach warhead, which is probably unnecessary for an anti-ship missile. Reducing that to a perfectly adequate 500 pounds would provide substantially more room for greater internal fuel volume. Launching from a surface platform may also decrease the total range, depending on the rocket booster. Australia has already purchased 200 weapons for use with the Super Hornet fleet, and Lockheed Martin and Thales Australia, pronounced Thales if you are a Frenchman, are jointly developing the surface-launched variant, which will be able to be deployed by warships and, potentially, ground vehicles as well. The key advantage the LRASM provides over other contemporary anti-ship systems is its range. The weapon allows the launch platform to stand off well beyond the ship's missile defences. So this all sounds great, but where does the Arafura class come in? Well, what the ADF has constructed with this greater complex, this system of systems, is a battle network. The term battle network means much more than computerized data links. A battle network is any arrangement of military systems where the sensor and weapon are separated by a significant distance. An artillery observer and their parent battery are a battle network. What this means is the Arafura class can, in theory at least, play its part in the wider A2AD complex. The name of the game when engaging a hostile naval formation with anti-ship cruise missiles is saturation. Despite the LRASM's lethality, warships have formidable, layered defensive systems. The Type 52D, as an example, deploys the HHQ-9 long-range surface-to-air missile, essentially a navalised S-300 PMU, the HQ-10 point defence missile, and a 30mm close-in weapon system. These defences are compounded when the task force has 4 or 5 such warships. In order to penetrate these defences, you have to fire enough missiles at the targeted vessel that they simply cannot shoot them all down in time. The LRASM stealth only decreases the number of missiles required to achieve saturation. It does not eliminate this requirement. It is in this area that the Arafura class can play a meaningful role in this defensive naval battle. One of the main ways the PLA has made its A2AD complex so formidable is simply by the number of launch platforms it can deploy. Even its Yangdao corvettes have a capable anti-ship missile. The Jerusalem class, the design upon which the Arafura was based, currently fields the Exocet anti-ship missile in 4 canisters just behind the bridge. The Exocet is a much lighter weapon, just some 780 kilograms compared to the LRASM's 2 tons when equipped with its solid rocket booster. Therefore, there may be some challenges in deploying the LRASM on the Arafura class, especially with an additional 8 tons of weight that high up on the ship. However, if the LRASM can be deployed on the Arafura, then this offers a real opportunity to increase the volume of fire the ADF can direct at a hostile naval formation. Let's imagine a strike on a hostile carrier battle group as it enters the Molucca Sea off the island of Sulawesi, about 1,200 kilometers north of Darwin. A squadron of 16 Super Hornets departs RAAF Tyndall with 2 LRASMs apiece, deploying a total of 32 weapons. Now, what if just 5 of the Arafura class OPVs are operating in Indonesian waters, hiding in the littorals? The long range of the missiles means the small OPVs can open fire from the other side of islands like Timor or Sulawesi, making them very difficult to detect. With a coordinated strike using both land and air-launched LRASMs, the hostile naval formation now faces 52 incoming missiles, which can time their approach to ensure simultaneous prosecution. If only 10% make it through the defences, which is a low estimate, then the carrier would have sustained 5 crippling blows. In essence, because it is part of a wider battle network, the Arafura class would play a valuable role simply by acting as an LRASM launch platform. All it needs is a data link and the weapon itself. There is another area in which an LRASM-equipped Arafura class could substantially aid in a defensive naval battle. This is a concept called distributed lethality, which is a new development in the United States Navy's doctrine. In essence, the core idea behind the distributed lethality concept of operations is to overwhelm your enemy's ISR and targeting capacity by increasing both the number of platforms that pose a substantial threat and distributing those assets over a vast geographical area. Basically, instead of simply sailing into battle with 2 or 3 carrier strike groups, small task forces where ships are concentrated in order to provide mutual support, numerous vessels may operate independently. As all of these warships will be equipped with long-range strike weapons, such as LRASM and Tomahawk, and all will be provided with targeting data from a centralized fire control complex, deciding what targets deserve priority engagement becomes increasingly difficult. When offensive cyber and electronic warfare techniques are added to this operational picture, which will increase friction, uncertainty, and the number of false or phantom targets, the information burden will, at least in theory, saturate the enemy's command and control complex, specifically their ability to make tactical decisions. This burden may become crippling when the US begins striking command and control infrastructure. By increasing the number of platforms from which long-range strike systems can be launched, the ADF can achieve a similar effect. A hostile carrier strike group would, under this concept of operations, have to contend with dozens of surface platforms that can launch LRASMs, in addition to the RAAF and potentially the future submarine, vastly complicating their tactical picture, especially considering the ADF's electronic warfare capability. Thus, in terms of both the additional throw weight of an LRASM strike and in the generation of a more complex enemy targeting picture, equipping the Arafura class with the LRASM would do much to increase the ADF's overall capability in a high-end defensive naval campaign. This would require the development of a canister-launched variant of the LRASM, which could certainly be funded by the ADF alone, especially considering Australian defence industry is already developing the missile. If the Arafura class was intended to be used in this high-end warfighting role, where the anti-ship cruise missile threat is substantial, there is a case for arming the vessels with a point defense gun or missile capability. A weapon like the C-RAM, a version of the rolling airframe missile which has its own dedicated radar system, would be ideal, allowing the vessel to engage air threats at a range of up to 10 kilometers. Nonetheless, even a phalanx close-in weapon system would probably do. These weapons could even be placed in the area which is currently reserved for the 40mm gun, as they would be of much more utility within this operational concept. An Arafura class armed in such a fashion could also be useful for task force operations operating a long way from home. Adding a pair of OPVs to a task force would provide the same LRASM capacity as a single destroyer. The other major area of naval combat where the Arafura class could be of substantial value is in the role of anti-submarine warfare. Just like the A2AD concept, in order to utilize the Arafura to hunt submarines, it needs to be part of a battle network. These small vessels will never be able to have the weapons and sensors to prosecute hostile submarines alone. But when used in combination with a Hunter or Hobart-class destroyer, they could significantly increase a task force's sensor footprint. The Arafura is designed to use modular, containerized mission packages. A mine warfare package is already under development for the class. In essence, if you want to change the role of the vessel, you simply load the specific mission package. Two 20-foot containers can be accommodated on the flight deck, allowing for UAV or mine warfare operations. There is a possibility that an anti-submarine warfare module could also be acquired. Ultra Electronics, the manufacturer of the Hobart-class sonar suite, has developed a small, containerized towed array sonar system. Called the Sea Lancer mission module, the single 20-foot container contains the towed array and its supporting computer systems. The Sea Lancer can be configured as a passive or active sonar, with low-frequency active modes enabled by a horizontal projector array. The container is a standard 20-foot size and weighs 14 tons when fully loaded. All that is required to support sonar operations is a 30 kilowatt electrical power source. With the Sea Lancer mission module installed, the humble Arafura class now poses a serious threat to enemy submarines. When paired with a major surface combatant, such as an Anzac-class frigate, the Arafura can data link its sonar to the larger warship, allowing for off-board signal processing. With two passive towed array sonars in combination, the task force can rapidly triangulate detected targets. But its real advantage is realized in a multi-static architecture. In a bistatic or multi-static sonar complex, a single active source, or ping, is received by multiple passive sonars. Multi-static sonars offer significant increases in performance. As the two or more receiving sonars are widely separated, it is much easier to filter out background reflections, greatly increasing the system's resolution. Additionally, as the echoes are received at multiple positions, they can be rapidly triangulated, giving precise track data. This effect is increased with multiple active systems. One of the main new capabilities the Hunter-class frigate will provide the ADF is a high-power, low-frequency active sonar system. Low-frequency active systems are specifically designed to detect and track very quiet submarines at long range. If integrated with the Hunter class, a Sea Lancer-equipped Arafura class OPV would allow the creation of a bistatic, low-frequency active sonar complex, substantially increasing the capability of the Hunter's sensors. Once a target is detected and tracked, it can be engaged by the Hunter's anti-submarine helicopter, the dipping sonar-equipped MH-60 Romeo Seahawk. Australia, just in general terms, has to maximise the capability of its limited assets. The nation's sea lines of communication are vast, and there is only a limited number of warships available for commerce protection. By equipping the Arafura with its own towed array sonar, this will greatly increase the capability of the RAN's major surface combatants. One could easily imagine the formation of several Hunter-killer groups composed of a Hunter-class frigate and Arafura-class OPV operating in tandem. Anti-submarine warfare is a multi-platform game, and coordinated prosecution by multiple vessels and aircraft is the primary way submarines are sunk by surface forces. By equipping the Arafuras with their own highly capable sonar systems, this allows the Hunter-class frigates to operate individually, each teamed with an Arafura, meaning the vessels can be in more places at once. The modularity of the Sea Lancer system, and those like it, allow the Arafura to be reconfigured for border protection or mine warfare in a matter of hours, meaning no capability has been lost in real terms. If the Arafura class OPV was equipped to fulfil these high-end warfighting roles, it could provide the Royal Australian Navy with essential mass, all at comparatively low cost. Perhaps a good comparison is the RAAF's Loyal Wingman combat drone, otherwise known as Boeing's air power teaming system. Each Loyal Wingman drone is much less capable than an F-35A, but when used in a network team they greatly enhance the capability of the much more expensive platform. They can also take over the more mundane roles, such as defending tankers and airborne early warning and control aircraft, allowing the manned fighters to tackle more critical missions. In a similar way, the small and cheap Arafura could supplement or replace Australia's high-end warships, enhancing their capability and allowing them to be in more places simultaneously. This is critical for the ADF which, technologically advanced though it is, has to make a limited number of assets go a long way. Originally a class of 20 OPVs were envisaged by the 2009 Defence White Paper, however that has now been curtailed to 12. in addition to 2 dedicated mine countermeasure vessels. There is spare capacity, both in the budget and in Australian shipyards, to increase the total number of Arafura class vessels to 20. The total program cost for the C1180 project is currently estimated to be $3.6 billion, leading to a unit cost of around $300 million in 2018 dollars. Nevertheless, as unit costs tend to decrease with time over a production run, we should expect any additional units to cost far less, perhaps down to the $100 million range. An additional 8 units may only increase the total program cost of C1180 by $1 billion. Just to put that into perspective, in 2021, over a single year, Australia allocated $15.8 billion to platform acquisition. Obviously, the additional capabilities discussed here, such as Sea Lancer and LRASM, would increase the cost somewhat, but this is certainly achievable given the current budgetary environment. Unlike the other major classes of warship that are being built in Australia, there is spare manufacturing capacity. The first 2 vessels, Arafura and Air, are being constructed at Adelaide's Osborne shipyard, but after that production is being moved to the Henderson facility in Western Australia. Once the 12th vessel is delivered in 2030, the naval shipbuilding plan only requires the replacement of the Cape-class patrol boats and the 2-ship Leeuwin-class survey vessels. These programs can certainly be moved to BAE shipyard in Melbourne. Therefore, there is certainly spare capacity at the Henderson yard to allow for continuous OPV production well into the 2030s. Finally, an increased OPV fleet should not be overly difficult to man. With a complement of 40, the 8 additional vessels would only impose a base crew requirement of 320, certainly not a deal breaker for an organisation with over 15,000 active personnel. The Arafura class promises to be a highly capable patrol vessel, and will certainly be a substantial improvement over the platform it is replacing in its intended roles. It is perfectly well fitted to be a highly effective patrol vessel, maintaining the integrity of Australia's maritime borders and its fisheries. Nevertheless, as has been shown here, the vessel has significant potential to be much more than a glorified patrol boat. It could be a serious warship, one that could substantially increase Australia's ability to fight a high-end naval battle and secure our sea lines of communication, the lifelines of any island nation. It is probably unlikely that Defence will look to utilise the OPV in these other roles, but if we do choose to do so, the Arafura could certainly be a key element in the ADF's wider warfighting capability.